This is number 11 on the sample final. This is a half-life problem. You've got a new element that's produced in the reactor. If 0.192 grams of this element decays, leaving only 0.092 grams after 124 days, what is the half-life? So we have two equations here that are important. You have x equals x naught over 2 to the n, and n equals time over half-life. So we're looking for half-life. So we're going to have to end up solving for n. We've got both of our x. Remember, x right here is how much is left over, and x naught is initial amount. So we need to solve the first equation in terms of n. So let's isolate n. If we multiply 2 to the n by both sides, we have x times 2 to the n equals x naught. Divide x by both sides, 2 to the n equals x naught divided by x. The way you get that n out of the exponent is to take the log of both sides. So we'll take log of 2 to the n, and have to take log of the other side, which would be x naught over x. That n now becomes a coefficient in front of the log. So we have n times log 2 equals log x naught over x. So then to isolate n, we're going to divide log 2 by both sides. So log of x naught divided by x over log 2. Now you can go through this derivation if you want to, but you can also just memorize this equation right there, because it's going to be the same whenever you're solving for n, and n's going to give you the time terms. So now we have this equation, we can plug in what we know. Our x naught is initial, and it said we have 0.192 grams. Final is 0.092. Divide this whole thing by log 2. You figure out that n equals 1.061. So now we're going to plug that over here. We know our t is 124 days. So n equals t over t to the half t to the half times n equals t to the half equals t divided by n. Our t was 124 days, and our n, which is the number of half-lives passed, is 1.061. 3 sig figs works out to be 117 days. So this is the half-life problem. This is number 11 of the sample funnel.